Hey guys, so let's review how to solve equations with square roots. Here are a couple examples of equations that contain a radical symbol in there. So this is going to work a little bit differently than equations that contain, say, a power of 2, but it's kind of similar. Let's read the instructions. It says solve for x as an exact value, simplify if necessary. So in this example, if we are left with a square root of a non-perfect square at any point, the problem is telling us that we should leave our answer in radical form, meaning if it's necessary, I will write my answer as some number, radical, some number. We'll see if that comes up. Let's try the first problem. Using inverse operations, I see that there are two things that I'm going to have to cancel out to get the x alone. One thing is I'm going to have to cancel this radical symbol. The other thing is I'm going to have to cancel this 12. I'm thinking about what's closest to x. I think this radical symbol is much closer than the 12, which means I can try to cancel the 12 first. To cancel addition of 12, I'm going to have to go ahead and subtract 12. I'll do that from both sides to keep my equation balanced. And what I'm left with on my left-hand side is radical x, and that has to equal 16. Now, what do I see? The square root of some number equals 16. Well, square root of what number equals 16? You might already know it in your head, but to actually show the workout, what we're going to do is square both sides of the equation. Squaring a radical will allow this to cancel. That allows my x to come down and finally be alone. On the other side, I'm going to now square 16. I'm going to get 256. That's not something I have to guess. That is exact. So I can go ahead and say that that is my exact answer. Let's check out this next problem. Now we have three different things going on. We have a 2 as a coefficient, we have a radical symbol, and we're subtracting 11. In order to really think about what I should get rid of first, I'm going to think about what's closest to x. Again, x is right underneath the radical, so that's the closest thing. The square root of x is the very last thing I'll be able to get rid of. Then I have this 2, and this coefficient, we know coefficients multiply to whatever follows them. So maybe I could rewrite this as 2 times radical x minus 11 equals 7. I think that might clear up some confusion for you down the road. The one thing I do want you to be clear about is that this 2 is actually a coefficient. It is not an index. It's not sitting up in the corner. We're not worried about it up there. It is, in fact, sitting out in front. Now I can go ahead and try to cancel. I see that the 11 is the furthest thing from x. I'm going to cancel that first through addition. I'm going to get 2 times the square root of x equals 18. Now I'm going to go ahead and cancel out this 2. Again, the radical symbol itself is directly surrounding the x. That's going to be the last thing I can get rid of. So I can cancel this 2 by dividing by 2. So the square root of x is equal to 9. So already in your head, you might be thinking of an answer. We're asking the square root of what number equals 9? Well, again, to show my work, I'm going to square both sides. That's going to cancel the radical out and allow the x to come down. And 9 squared equals 81. Again, I'm not guessing on that. That's an exact value. I don't need to simplify. I can just go ahead and circle it. So you're going to go ahead and try these three problems out. You can pause the video now and just copy them into your notebook. And when you're ready, come on back and we will reveal the answers. Alrighty, let's take a look at what we got. X equals 64. X equals 169. And x equals 49. If you have any questions, please just raise your hand and someone will come over.